In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills on average 40 workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows how quickly cave-ins lead to workers' deaths. The video will also show what employers must do to assure that the work can be done more safely. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll see that using the right type of protection saves lives. Please be advised, the scenes you're about to see deal with deaths at construction sites and might be disturbing for some people. All scenes are based on true stories. 5 workers were putting a sewer pipe into the bottom of a trench with a ladder nearby to enter the trench. There was nothing in place to protect the workers inside the trench if the walls collapsed. While the workers were inside the trench, one side began to collapse. 2 workers were able to climb out using the ladder, but the other 3 workers were buried in the soil and unfortunately suffocated to death from the weight of the soil. Let's look at the events leading up to this tragic incident and see how it could have been prevented. Employers must follow OSHA rules to protect workers in trenches. However, here, the employer did not follow OSHA's rules, which led to these workers losing their lives. Let's go over the main points of OSHA's rules for trenches to see how to keep workers safe. All trenches must follow OSHA's rules. 1 cubic yard of soil can weigh as much as a car, nearly 3,000 pounds. So unless the trench is cut entirely into stable rock, protection against cave-ins must be used for all trenches more than 5 feet deep, or for any trench that shows signs of cave-in. Before workers can do any work in a trench, a competent person must conduct an inspection to identify and remove any potential hazards. A competent person is someone who can recognize hazards in the area and who has authority to take quick actions to eliminate the hazard, which may include temporarily stopping the work. Inspections must be performed at the start of every shift, after a rainstorm, or whenever conditions change. The competent person must also test the soil in a trench. OSHA requires at least 1 test by looking at the soil and at least 1 test by hand. If a person knows the soil types, they can pick the right protective system to keep workers safe when they're in trenches. OSHA classifies soil in a trench as stable rock, Type A, Type B, or Type C soil. Stable rock is the safest soil for a trench. Type A is the next most stable, and then Type B. And finally, Type C soil is the least stable. It's important to remember that trenches can have different types of soil based on depth and climate conditions. The competent person can choose from different protective systems for a trench based on the types of soil found. For all trenches deeper than 5 feet deep, or for any trench that shows signs of cave-in, OSHA requires sloping, benching, shoring, or shielding to protect workers from cave-ins. Let's review each of these systems and then see how each one could be applied to the cave-in incident shown earlier. We'll look at sloping first. Sloping protects workers by cutting back the sides of the trench so the sides slant away from the trench. OSHA's rules identify the degree of slope allowed for each of the different soil types. When trenches are less than 20 feet deep, these are the basic maximum allowable slopes for each soil type. Stable rock can be vertical walls, but cannot be undercut. For Type A soil, OSHA requires that the walls be sloped 9 inches out for every 1 foot of trench depth. For Type B soil, OSHA requires that the walls be sloped 1 foot out for every 1 foot of trench depth. For Type C soil, OSHA requires that the walls be sloped 18 inches out for every 1 foot of trench depth. It's important to note that this kind of sloping can only be used for trenches less than 20 feet deep. Any deeper, and the protection must be designed by a registered professional engineer. So now, let's look at the workers in the original scene who were stuck in the trench as it started to cave in. But this time, the soil has been classified as Type B. The trench has been properly sloped, and the spoil pile is moved away from the edges of the trench. The trench walls are not caving in, and the workers are safe while they work. Now let's review the shoring type of protective system for trench workers. Shoring uses various support systems to prevent soil and the trench walls from moving. There are different kinds of shoring systems, but timber and aluminum hydraulic are the two basic types. Aluminum hydraulic cylinders are the most common type of shoring, and they are typically installed using spot bracing, plywood, or stacked methods. To install the shoring correctly, you must first determine the soil type. The type of soil and depth and width of the trench determine the maximum vertical and horizontal spacing used with the members of the shoring system. If we use our example of a 3-foot wide, 10-foot deep, 40-foot long trench in Type B soil, the shoring system being installed would need to include 12 strong aluminum vertical shores, with 6 on each side of the trench. These shores, also called rails, will be connected by hydraulic cylinders every 8 feet along the length of the trench. A hand pump pressurizes the hydraulic cylinders until they fit tightly within the rails. Now that the shoring is in place, let's look again at the workers in the trench at the beginning of the video. As before, the workers are laying a sewer pipe into the bottom of a trench. But now the shoring system prevents the trench walls from caving in and keeps the workers safe. Sloping and shoring are ways to protect the sides of the trench so they don't cave in. Now let's talk about shielding, which is a way to protect the workers when they're inside the trench. Shielding involves using trench boxes, also known as trench shields, or other supports to protect workers inside a trench from collapsing soil if a cave-in occurs. The competent person should pick a trench box that is right for the soil type and all other site conditions. A trench box has 2 large plates, which are held apart by 4 horizontal cross members. These plates, or shields, must be between the sides of the trench and the work area. The shields are strong enough to protect workers inside from a soil collapse. The shields can be 2 feet above the bottom of the trench as long as they can support the entire depth of the trench and there's no caving under or behind the shield. The top of the shield should extend at least 18 inches above the level of any materials that could cave into the trench. Trench boxes are typically used in open areas, but they can also be used with the sloping methods discussed earlier. So let's see how a trench box could have saved the workers that we saw at the beginning of the video. For our example, we'll assume that the workers are in a trench with Type C soil and no sloping, but working inside a trench box. This time, as the workers lay the sewer pipe into the bottom of the trench, they are protected from any possible cave-ins. This example shows the importance of employers following OSHA's excavation standards to ensure that workers are provided with a safe workplace. These types of construction deaths are preventable. The trench cave-in prevention measures shown here save workers' lives. Use these protections on the job. It could be the difference between life and death. If you would like more information, contact OSHA at www.osha.gov or 1-800-321-OSHA. That's 1-800-321-6742.